All right, let's look at some domains similar to what we've been working on in class. When we have a fraction, the only thing we need to do is say that the denominator cannot be equal to 0. And in this case, when we subtract that, all right, looking at number 40, talking about domains, we've got our ways to restrict domains. We've got fractions, square roots, and logs. So the first one is a fraction, and anything in the denominator cannot be equal to 0, can't divide by 0. But in this one, when we subtract that 1 over, we know that x squared can never be equal to -1 anyway. So the domain of that guy there is going to end up being all real numbers. The next one, we can kind of take it piece by piece. In this one, x cannot be 0. And in this one, x plus 1 cannot be 0, so x cannot be -1. So the domain would be all real numbers except for 0 and -1. And we could write that in interval notation if we wanted, from -infinity to -1, from -1 to 0, and from 0 to infinity. Or we can just say x cannot be -1 and 0. But realizing that we might see either one on an assessment or an AP test, of course. All right, I like number C. X squared minus 9 has to be greater than or equal to 0. So x squared has to be greater than 9. Now a lot of kids are just going to take the square root and say x has to be greater than or equal to 3. But we need to remember when we take that square root, it's actually x has to be greater than or equal to the absolute value of 3. Because it could be a -3 squared. And that would be equal to 3 as well. So what that means is, and when we do this, we kind of use one and then switch both. And what I mean by that is x is greater than or equal to 3. So I use this exactly. And then the other word I said is we switch both. X is less than or equal to -3. So I used one and I switched both. And you could double check that by just putting numbers in. X is greater than or equal to 3. If I put a 4 there, does that work? 16 minus 9, that's a positive number, good to go. Same here, if I put a -4 in, same thing, 16 minus 9. So that is my domain. And I can write that in interval notation. Let's grab another color for this one. -infinity to -3, and 3 to infinity. That's kind of a cool one. We go from -infinity to -3. We skip everything in between, skip 0, -2, all those, and then we keep going. All right, now the last one, we talk about most restrictive. In the denominator, x plus 4 has to be greater than 0. Now usually, we say square roots have to be greater than or equal to 0, but because this one's in a denominator as well, it can't be 0. So therefore, it has to be greater than 0. So x has to be greater than -4 for the denominator to be true. And then we look in the numerator. X minus 3 also has to be greater than 0. Logs always have to be greater than 0. So x has to be greater than 3. Now which one is more restrictive? X has to be greater than -4. X has to be greater than 3. This one is more restrictive, so it is the entire domain for this problem. Good. Very good domain range work. I would definitely practice that. I'm going to show up all year long.